Hey, welcome to The Explainer. In every single factory and plant, there's a gold mine of data that holds the key to preventing major failures. But here's the catch. Most of it is just messy, inconsistent, and it gets totally lost. So today, we're going to explain how you can unlock that data and turn it into an absolutely powerful tool for getting better every single day. Oh man, we've all seen this, right? You get a critical breakdown, a technician rushes in, they totally save the day, and then they close out the work order with this note. Fixed pump. Okay, great. The immediate crisis is over. But there's a much bigger problem hiding right there in plain sight. Yeah, exactly. What did we actually learn from that? We know the pump is running again, sure. But why did it fail? Was it the same reason it failed last time? Was it a bearing, a seal, the motor? That little note tells us absolutely nothing. And you know what? That lost knowledge costs real money in repeat failures and just wasted time. So this leads us right into what the source material calls the mystery failure problem. When our failure data is this vague, and let's be honest, it's usually because of time pressure or a culture that just prioritizes speed over everything, every single breakdown feels like a brand new mystery, even if it's the same old villain in disguise. It keeps teams completely stuck in a reactive mode, always fighting fires instead of actually preventing them. I mean, think about it. If every technician describes a problem using their own words, their own slang, there's just no way you're going to spot a pattern. You can't analyze a bunch of random anecdotes. So all these valuable lessons from every failure, they just slip right through the cracks. And before you know it, the same problems start creeping back in, over and over and over again. So how do we break this cycle? Well, we move from guesswork to data. And this means building something called a failure catalog, which is basically a structured, standardized library of how things fail. It's a huge shift, not just in your process, but in your whole mindset. So let's actually break down what that transformation really looks like. What's really cool here is how it completely changes troubleshooting. Right now, a lot of places rely on the memory of their most senior technician, right? The person who's seen it all. Well, in this future state, anyone can instantly pull up a full, structured history of that piece of equipment. No more digging through messy, handwritten notes. You can immediately see a crystal clear record of problems, causes, and the actions that actually fix them. Okay, and this is where it gets really powerful. It transforms how you make the big decisions. Instead of just going with a hunch or whoever shouts the loudest, you can use hard data. You can run a simple Pareto analysis, the 80-20 rule, and find out that, hey, maybe 20% of our failure modes are causing 80% of our downtime. All of a sudden, you're not guessing anymore. You're pinpointing the exact bad actor equipment with undeniable proof. But honestly, the biggest change of all, it's the mindset. This slide just nails it. We move from a culture of just fix it, get it running, to one of, okay, let's learn from it. The focus shifts away from just the immediate repair and onto understanding the root cause, with the real goal being to prevent that failure from ever happening again. So what's the tool that gets us there? Well, it's a beautifully simple and really powerful framework called Problem, Cause, Action, or PCA. You can think of this as the engine that's going to build your failure catalog. The best way to think about this comes right from the source material. It's basically a doctor's diagnosis for your equipment. It's brilliant. Just like medical codes make sure every doctor everywhere describes the same illness in the exact same way, failure codes make sure every technician documents a failure consistently. And that consistency, that's the absolute key to being able to analyze anything. Let's break it down. It's a really simple three-step logic. First step, the problem. What was the symptom? What did the operator actually see? The pump failed to start. Got it. Second, the cause. What was the real root of that problem? The pump coupling was misaligned. And finally, third, the action. So what did you do to fix it? Realigned the coupling. It's simple, it's logical, and it's complete. And right here, this is the magic. Just look at this side by side. On the left, our old friend fixed the pump. It's a data dead end. But on the right, you have the exact same event captured with the PCA framework. It's not a note anymore. It's a rich, analyzable data point that tells a complete story. It's night and day. Okay, so you're probably thinking, this sounds good, but what's the real payoff? Why go through the effort? Well, let me tell you, the benefits are huge. With structured data, you can pinpoint root causes in minutes, not days. You can fine-tune your preventative maintenance to target the failures that actually happen. You can walk into that budget meeting with a graph that proves exactly why you need that equipment upgrade. And maybe the most important thing of all, you captured the priceless knowledge of your senior technicians, creating a collective memory that doesn't just walk out the door when someone retires. Okay, theory is one thing. Let's talk about how this actually works in the real world. Let's look at a case study. So check out the story of this one centrifugal pump. It just kept failing. Now, the first time it broke, the structured data showed the cause was improper lubrication. 6 months later, it fails again, but this time the cause code points to misalignment. Then, 8 months after that, a huge, catastrophic failure. The cause this time? A defective part. Now, without structured data, this would have just looked like the pump keeps breaking. With it, they saw a crystal clear pattern of different, shifting root causes. All right, before we get to the big reveal, let's quickly cover a key metric here: mean time between failures, or MTBF. It's just what it sounds like, the average time a machine runs between breakdowns. The higher that number, the more reliable your equipment is. And this is the number the team was trying to fix. So what did they do with all this amazing data? It didn't just sit in a report, it drove action. They rolled out a new precision alignment procedure for all similar pumps. They updated the lubrication schedule, and they actually worked with their supplier to recall the entire bad batch of parts. See, these weren't random guesses, they were targeted solutions to data-proven problems. And the result? Get this, more than a year of failure-free operation. They didn't just fix the pump, they completely broke the cycle of failure. That one number right there proves the entire concept. They made that pump more reliable than it had ever been, simply by learning from its failures. And you know, this really brings us to the biggest takeaway of all. This isn't just about data or metrics or software. It's about fundamentally changing the culture of your entire organization. This quote from the source material just sums it up perfectly. When your leadership starts asking, what did we learn from it, instead of just, did you fix it? That's when you know you've won. It's a signal that every single maintenance job is now seen as a chance to get smarter and stronger as a team. So at the end of the day, a failure catalog isn't just a different way to type in data. It is a system for building a collective memory, a powerful knowledge base that stops you from solving the same problem over and over again and makes your entire operation smarter. And that leaves us with one final thought, really a question for you. Take a second and think about your own operations. What patterns, what repeat failures, what crucial money-saving knowledge is hiding in your maintenance logs right now, just waiting for someone to find it? Thanks for joining us for this explainer.